All right, so today we are going to be learning about what it is like to be a scientist. So put your white coat on, put on your white coat, and we're gonna figure out what it's like to be a scientist by learning what the scientific method is. So to start, I'm gonna ask you guys, what do you know about being a scientist? And why do scientists create hypotheses, and why do they test them? We're going to write our answers on the board because later we're going to reflect on them. So for starters, what do you know about being a scientist? What background knowledge do you have? It can be the most basic thing. Like I said, they wear white coats, so they can wear white coats.
They work in labs.
Okay. Work in labs.
They test things.
Okay.
They back up theories or like test theories.
How do you think they come up with the questions, or how do you think they come up with things to test? What do you think? Do you think they just like walk around and find things and they're like, let's test them? Or we can move to the next question and say, why do scientists create hypotheses and why do they test them?
They're interested in other things.
Okay.
Like finding out, or to back up their theory.
I think so. Or they want to back up there. So do you think that these theories and the hypothesis, do you know anything else about a hypothesis, like what is put into making one?
An if-then statement.
Okay. And do you think sometimes scientists are wrong? Are they always correct? Would you say that a majority of the time they keep creating experiments because they end up being wrong and they need to find the next solution? Okay. So, then, next we're going to watch a video to get you intrigued on the scientific method and what it is. So does anyone remember what the first step was? It's okay if you don't. So,
Make an observation.
yep. So our first step is to make an observation or present or pose a question. So today our question is, how do items float? Have you ever seen a big cruise ship floating in the middle of the ocean and you're just like, how does it float? Because it's so big, there's so many people on it, so much food on it, and there's so much to do on a cruise. Yet it's floating and the water's holding it up. So what we're specifically going to talk about is volume. And this is all going to lead to a science experiment that we're going to do in a little. So our next step is to do background research. So you can pull out your device that I asked you to bring to class, and we're going to do a little bit of research. So since we're talking about volume and floating, we want to get a definition of volume, and we want to figure out what floating is as well. So when you figure anything out, you can let me know, and we're going to write it on the board so that we can reflect to it throughout the class.
Volume is the amount of space that a substance or object occupies.
The amount of space a subject occupies?
Yeah.
And do we find anything on floating?
Buoyant or suspended in water or air.
Can you spell that?
B-U-O-Y-A-N-T.
Buoyant or
Suspended in water or air.
now why would it say water or air? Why would it say air? Like things only float on water.
Balloons float in the air.
Yeah, exactly. That's exactly it. So we have to consider that as well. What we're specifically going to focus on is like floating in water and like how that leaf right there is floating in water. So now that we did our research, we found background information, we're going to do an experiment, but the first step is to form a hypothesis. So since this is your first time writing a hypothesis, I'm going to give it to you, but we're going to break it down and talk about all the different aspects of what a hypothesis makes. Then this exact slide is on your notes, so if you need to take any extra notes, you can take it on there. But I broke it down so it's something you can always reflect back to. Each color in the hypothesis stands for something else, and it's explained down here. So today our experiment involves foil, water, empty containers, and then a hypothesis that we're going to test. So our hypothesis is if objects, foil balls, which we're going to use, have a higher volume, so if they're crushed up more, then they will not be able to float in water. So basically what we're asking is which ones will float and which ones will sink. We know that volume is the amount of space that a subject takes up. So obviously the smallest ball will have the smallest amount of volume, and the largest one will have the largest amount of volume. So we're going to test that. The three key things you have to keep in mind when you're forming a hypothesis is that it's an if-then statement, like Rayanne said earlier. So if you do one thing, then another thing is going to happen. So in this case, if the objects have a higher volume, then they will be able to float. The other thing to keep in mind is that something is always going to be changed in an experiment. So what will be changed per trial for us is the size of the foil balls. And then the last thing to keep in mind is that something will stay the same. So we're going to test if they will be able to float or not, which will either stay the same or change. But we're we're keeping the sizes all the same, and you're each going to do your own testing. So if you flip to the next page on your notes, there's a table, and we have the smallest, the smaller, the large, and then the largest, because you want to have multiple sizes when testing your experiment to see if it truly works. I brought some for both of you so we can collect more data, because the more data you have, the better your hypothesis will turn out. So we're going to test each one. You're going to check off if it floats, sinks, or if it's like kind of in the middle, because sometimes it doesn't float or it doesn't sink. So can each pour in the whole bottle of water into a container. And then you can either start with the largest or the smallest, and you're going to put it in. And to really know if it sinks or floats, you're going to want to tap it. Because if it floats, it's going to pop back up. Whereas if you you're going to see how it submerges. If you take the tiny one and you push it down, it's going to pop back up. Whereas the big one, it mainly stays down.
Can we put these into it?
Yep. So then, based off our experiment, you can see that the biggest volumes, so our largest balls, are more likely to sink than the small ones. So for the smallest and the small, you can tell they're definitely floating because when you push it down, it pops right back up. For the largest and large, the large one, it's kind of in the middle, as you can see. Didn't go all the way down. But the largest one, it's pretty stuck there on the bottom. So now that we're done with that, we are going to do a 3, 2, 1 countdown, which is on the next page. It's just to test what we've done so far. And you're going to write 3 things you've learned, 2 things that have surprised you, and 1 thing you still want to learn about the scientific method.
So you don't anything, right?
Yes. If you're not finished, it's okay. We can come back to it later. But we're going to move on. And now we're going to assess our hypothesis. And we're just going to talk about it for now. We want to analyze our data and draw a conclusion about it. So looking at our results from the experiment, what did you find overall? Based on our results, what did we find?
The largest ball sinks to the bottom.
Yep.
The smallest ones float.
And how do the different volumes compare when floating? It's exactly what you just said, actually.
Yeah.
So it's the same thing. We found that the larger the volume, it's going to sink, and the smaller the volume, so the smaller space it takes up, the more likely it is to float. So going back to our hypothesis, If objects have a higher volume, then they will not be able to float. Were we correct or incorrect with our hypothesis after finding our data? Okay, and we knew this was correct because we tested it. And this is what scientists do on a daily. They form their hypothesis and they test it. And it could take them months to test this, but at the end they're going to reflect and say, did this work? Did it not? What can I do next time to make sure I get the results that I'm looking for? So, now we're going to generalize about our findings. So, on the last page, there are 2 questions that we're going to go over. So then, the first one is, we're going to use these sentence starters. So if you just want to write 1 sentence for the first question, 1 sentence for the second question. And you want to use these sentence starters on the board because it helps you to draw that conclusion, and they're great ways to start off your collection. And then we're going to share one, you're going to share 1 answer from either question. So, if you're ready, if one of you could just share your response to either question.
I said, overall, our data showed that volume is dependent on whether an object sinks or floats.
That's perfect. You brought up all the points. And our last step is to share your process and our results, which we just did with the group. So now for our last part of the lesson, we're going to do a hand it in and pass it out. So if you take the note card, you're going to write any of the steps you remember, and then we're going to hand it in and pass it back out. So just write whatever you remember. And then when you finish, you can give it to me. Okay. And then we're going to switch them actually, and you can correct the person who's next to you based off your notes. And then we are going to go over the correct. So now we're going to take our quiz.